Welcome back, engineers. Let's continue our discussion on system design numbers, and we are going to discuss availability today. I hope you're ready. Let's get started. So what is availability? It is the percentage of time a system is operational and is able to serve requests, right? So let's take an example of a hospital to understand this. Let's say in a hospital, there are two departments. One is the emergency department and the other is the outpatient department, right? So the emergency department is open 24 hours. Right, open throughout the day, but the outpatient department, let's say, closes at 9 p.m. right? So what is the availability of this hospital? So for this department, we are open 24 hours, so this is nearly about 100% available, and this is closing about 9 p.m., which is about 75% available, right? So we are looking at a percentage of time a system is operational and is able to serve requests. So in this case, the emergency ward is able to serve new patients whenever they come in, irrespective of time. But in the outpatient department, there is a specific time slot, we need to take appointments and so on. So when we talk about this in the computer world, we want our servers to be up and running all the time, but keeping it up and running comes with a cost, right? So we need to understand the trade-off between how much uptime is required, or rather how much downtime is tolerated, right? So let's have a closer look at these numbers. So generally, when people talk about availability targets, they talk about 9's, right? So this is the language of 9's, and this is what is commonly used in availability. So let's go through this. Let's say we want 99% availability, which is 2 9's, right? So what does this mean, 99%? So in a year, there are 365 days, right? So if we remove 1% from it, we get about 3.65 days a year where the server will not be up and running, right? So that is what 99% means. So we are okay with about 7 hours of downtime per month, which is roughly about 3.65 days per year, right? So this is kind of acceptable for non-critical systems, probably for some internal tools and things like that, right? Now let's add one more 9 to this. We are adding 3 9's, which is 99.9% availability. So this is coming out to be around 8.77 hours per year, which is about 43 minutes per month of downtime, right? So this is the common availability target for many web applications. We will be mostly okay with 99.9% of availability, right? So if your system is more critical, we would like to go for 99.99%, which is 4 9's, right? So this is just about 50 minutes per year, or just 4 minutes per month of downtime, right? So this is a very high availability standard, and this is mainly used for large applications, like public facing applications, mainly like e-commerce or social media, right? And if you want to go beyond that, 99.999, which is 5 9's, we are just getting 5 minutes per year as a downtime, right? So this is the gold standard for very critical infrastructure like telecom and payment gateways, right? Very critical systems, 99.999%. So these are the targets that we can set depending on the use case of our application and the user base and so on, right? So what does this even mean? What does it mean when I want a target of 99% or 99.9%, right? Let's have a closer look at what the infrastructure will look like. So let's say we want a target of 99%. So this 99% is protecting against nothing. So it is just a user connecting to a single server and a DB. This whole thing is one box, right? So if this box goes down, everything goes down. So this setup suffers from single point of failure, and repair is manual, right? That's why we get 3.65 days per year of downtime, around 7 hours per month, right? Now, if you go to 99.9%, it is giving us a protection from single point of failure, which was the deal with 99%. And with this, we are getting a load balancer. So we are having 2 app servers and a load balancer. So if one of the app servers goes down, our system is still up and running. So we have protected ourselves from single point of failure, right? And also on the database side, we have 2 DBs now. One is a primary DB and another one is a standby DB. And we are doing a asynchronous replication for keeping the databases in sync, right? So this kind of setup is protecting from single point of failure, but this suffers from data center failure because this whole thing is in one data center, right? That's what we see here. This whole thing is in same data center, and this is suffering from data center failure. So we go to 99.99%, which is 4 9's, and we are protecting from data center failure here. So what do we do now? We go to availability zones. We distribute the infrastructure into 2 different availability zones, right? So they're in the same region, but they are in two different availability zones. So these two availability zones are nothing but two different data centers, and maybe they are separated apart from each other through some distance, right? Maybe they are in the same city or outskirts of two cities, but we have two different data centers and we are protected from a single data center failure. So if one whole data center fails, we still have another data center with the same setup that we have seen earlier, and our system is still up and running, right? However, this suffers from region failure. If the entire geographical region goes down, we are in a trouble. So we go to 99.999%, which are 5 nines, right? So this protects us from entire region failure, right? So what do we do here? We distribute our infra into two different regions. Every region will have different data centers, and data centers will have load balancers with multiple app servers and backup databases and so on. And the same thing is distributed across two regions. So if an entire geographical region goes down, we still have another region as a backup, right? So this is how we can use the different nines. But even this one can suffer from global outage. So let's say AWS is down for the entire world, then it doesn't matter how many regions we still have global outage, right? So how do we protect from that? So this is a very rare situation. So if you are going beyond 99999, you're looking at setup with multiple cloud providers, and that is a very complex setup and quite expensive to maintain as well, right? So it's not just about throwing money at these servers and taking up backups of backups, right? We are also responsible for maintaining it, monitoring it, keep observing if the data is getting backed up or not, do failure runs to see if the backup servers are coming up online, and so on, right? So it's important to understand not to take these setups at face value. Do your own due diligence, keep your costs in mind, keep your users in mind. What is the real level of availability that you mostly need, and you can choose a target for that. So you can use these setups like a benchmark or a baseline, right? So that's how availability numbers work in system design. So I hope you got some clarity about how to deal with availability targets. If you have any questions, definitely let me know in the comments below. That's all I had for this video. Please leave a like if you found this helpful, and thank you so much for watching. I will see you in the next one. Please subscribe if you haven't done already so that you don't miss out. Thank you so much for watching. I will see you in the next one. Cheers.